Welcome to our channel, my dear students. Today we are going to talk about the previous year, that is last year CBSE Board Chemistry questions, part 23, in which we are going to discuss the aldehydes, ketones and carboxylic acid chapter. So here the first question is, write the structure of the product formed in the following reaction. This was asked in the year of 2012, and here it is what we know that it's nothing but Friedal-Crafts acylation or alkylation reaction. Here the Friedal-Crafts acylation reaction may takes place. So here initially we need to form an electrophile. So by that way I had to form an electrophile when it is react with AlCl3, which will be reacting with our reactant, one of the reactants C2H5COCl. Along with that it forms AlCl4 minus, along with that C2H5C double band O plus. Okay, that is what I will be getting. What is that? Electrophile. Now this is the electrophile. This is electrophile which is going to contribute in the reaction. By that way, one double bond benzene I have to write like this. So here a bond is getting shifted, and here this C double band O plus is there, and C2H5 group is there. This will be getting negative charge, this will be getting a positive charge, this positive charge will come and approach a negative. So by that way I'll be getting the product like this. So here it is, one positive charge is there is no change in this bond, and this bond, there is no change in this bonds, but here one C double band O, C2H5 group is getting attached. By the way, one more hydrogen is there. Okay, if this hydrogen wants to leave on its place on its own, because it need to satisfy the carbon balancing. That is what it leaves as H plus. Once it leaves as H plus, what about the charge? I'll be getting negative charge. These negative charge and these positive charge will form a double bond to maintain a aromaticity. So I'll be getting a product like this, C double band O, C2H5. So here what I'm getting the product? So I'll be getting a product like this, that is C double band O, C2H5. This is what I'll be getting a product in that case. Are you able to understand, student? Such a simple mechanism. Just we have to react with anhydrous aluminum chloride, that will be forming an electrophile. After forming an electrophile, that will come and attack the benzene ring. Okay, then the benzene ring will leave the electrons. The electron will rich center is formed. The electron rich center is going to attack the electrophile. By the way, I'll be getting a product. And next one is predict the organic product of the following reaction. So here NaCN and HCl. So once NaCN and HCl, NaCN and HCl is there, what will be the product? NaCl with HCN. So here HCN will be formed. So Cn minus will be acting as a strong nucleophile. So here if I'm taking a reaction like this, say for example, this is the benzene ring what I'm having, and C double band O, H I'll be writing, and COOH is there. Okay, if it is react, if Cn minus will come and attack. So Cn minus will come and attack the electropositive carbon, because it has slight negative charge, it has slight positive charge. By the way, the Cn minus will come and attack the positive charge carbon. Okay, so this is the carbonyl carbon. So this carbon will be attacked. By the way, I'll be getting a product like this. So here it is O, and C, here it is O minus, here one H is there, and Cn is there. Okay, now what happened? So here COOH. If I'm acidified it, if I'm giving a H plus, so what will be the product? So I'll be getting a product, or otherwise this H plus wants to move on its own. By the way, I'll be getting the product like this, CHOH. So not like that. So H plus if I'm giving, so I'll be getting a product like this, because the carbon wants to get, here COOH is there, and here it is CHOH, and Cn is there. That is my ultimate product. This is nothing but a cyanohydride. The respective product of cyanohydride I'll be getting. Are you able to understand? This H plus will, here H plus and Cn minus is there. Okay, the Cn minus will come and attack. The remaining H plus is there. H plus will be easily attached with this O minus to form OH. So that's what I will be getting, cyanohydride. Okay, and next one is predict the products of the following reactions. So by the way, they will be giving one ketone. Okay, that's nothing but acetophenone they are giving. So if acetophenone, if any aldehyde or ketone or carbonyl compounds generally react with ammonia derivatives. What are all the ammonia derivatives? That may be amines like this, hydroxylamine, hydrazine, phenylhydrazine, or 2,4 DNP or 2,4 dinitrophenylhydrazine, or otherwise semicarbazide. If anything will come and react with this aldehyde or ketones or any carbonyl groups, so what it form? So this H2NO will leaves as water molecule. By that way, I'll be getting a product. You just think of it. So it is very simple reaction. So you no need to confuse it that much. So here I'll be writing CH3 with the double bond, and the N you have to attach, and CH2. So here CH3 is there. Just eliminate water molecule, the remaining product you just write as it is. Are you able to understand, students? Any of the ammonia derivatives, like maybe amines like this, then hydroxylamine, hydrazine, phenylhydrazine, 2,4 dinitrophenylhydrazine, or semicarbazide, whatever it may come in the case of ammonia derivatives. If it is react with our carbonyl compounds like aldehydes and ketones, it removes water molecule by the way just forming a compound like this. Okay, are you able to understand, students? Okay, and next one is convert the following cyclohexanol to cyclohexanone. This is very most important one. Cyclohexanol. What is the structure of cyclohexanol? So this is a cyclohexane. Okay, so in which if I'm having OH group, that will be called cyclohexanol. So what about the cyclohexanone? So in the same ring, I will be having C double band O group. Okay, that is called cyclohexanone. This is the cyclohexanol to cyclohexanone. So here I have to use the reagent. What kind of reagent? So it may be a CrO3. Okay, chromic oxide with sulfuric acid. Okay, but nothing but get oxidized. So it gets a strong oxidizing agent. The strong oxidizing agent will convert the alcohol directly into ketones. Okay, so here so I have to convert by using this kind of reagents like chromic acid and H2SO4. By the way, get oxidized to form ketone as a product. And next one is illustrate the following reaction, that is Wolff-Kishner reaction, Wolff-Kishner reduction. So it's a very important reaction. So Wolff-Kishner reaction, say for example, if I'm taking a ketone CH3, C double band O, CH3. Okay, so it will be reacting with hydrazine, that is NH2. It's a kind of ammonia derivative. So this ammonia derivative will react with this ketone to form what kind of compounds? In presence of a base. In presence of a base, I will be getting the product like this. So what kind of product? So this CO group is getting converted into CH2 group. So that is what? CH3, CH2, CH3. Okay, so I will be getting converted that CO group into CH2 group. That is what I will be using this kind of reagent. This is a Wolff-Kishner reduction. So initially these CH3, C double band O, or I can write like the C double band O, and CH3 is there. With that, there is a H2, NH2. So as I told earlier, so whenever the ammonia derivative will come and react with the carbonyl compounds, so it will be eliminating the water molecule. With the elimination of water molecule, I will be getting a product CH3, C single bond CH3. Here one double bond is existing, and NH2. This is nothing but hydrazone. Once the hydrazone is getting formed, which will be reacting with KOH in presence of ethylene glycol. Ethylene glycol as a product. So ethylene glycol as a solvent. These kind of solvent in presence of a base, so which eliminates the nitrogen gas. So which eliminates the nitrogen gas at the same time addition of the hydrogen. So by that way, I will be getting a product CH3, CH2, CH3. Okay, I will be giving you the reaction mechanism in another video. You just go and watch and get idea about this mechanism. And next one is a Cannizzaro reaction. What is the Cannizzaro reaction? Cannizzaro reaction, the important condition is, so without alpha hydrogen. Without alpha hydrogen. So it should not, the reactant should not have any alpha hydrogen. That time only this Cannizzaro reaction may take place. Say for example, if I'm taking an example like C double band OH. So this is a functional group. This is our functional group. So here there is no alpha carbon is also not even a alpha carbon is there. If there is no alpha carbon, there is no alpha hydrogen. Okay, so the alpha hydrogen is nothing but, say for example, if I am writing a product like that, CH3, CH2, CHO. At the time, this is a functional group, this is the alpha carbon. So in this, I have 2 hydrogen, that is what I can use alpha hydrogen. Okay, so here this HCHO, another molecule of HC double band HO will react in presence of a strong base sodium hydroxide. I'll be getting a product HC double band OONA, along with that CH2 CH3OH. I'll be getting a product. Are able to understand, students? So I'll be getting, this is nothing but it is a good example of disproportionation reaction. Likewise, I'll be getting one oxidized product and one reduced product from aldehyde. Aldehyde getting oxidized to form acid, aldehyde getting reduced to form alcohol. That is what this reaction is otherwise called as a disproportionation reaction. Okay, so by the way, I'll be getting a product. So here HC double band OH is there. The first molecule which is going to react with our base, the base will come and attack the carbon, carbonyl carbon. So by the way that HCO minus, and here also H, here also OH. So I'll be getting HCOOH. Okay, this H plus, this H minus wants to move. Why it wants to move as H minus? Because I am in need of positive charge here to form a double bond. So that is what it will be moving as H minus. So which will move as H minus. This H minus will come and attack another molecule, that is another molecule of formaldehyde. So that I'll be attacking this same thing, that is a HCO minus H, one more H is there. That is what, if I am acidify with H plus, I'll be getting CH3OH as a product. Are able to understand, students? This is the very most important thing. It's a good example of disproportionation reaction. By the way, here aldehyde initially attacked by base, so which forms this kind of compound, and here it need to form a double bond with the HCOOH. Acidic product will be getting formed. Along with that, our H minus wants to leave. The moving H minus ions will able to react with the another molecule, second molecule of this. This is the first molecule, this first molecule, second molecule, this is second molecule. The second molecule will able to react attacked by H minus formed in the first reaction. By that way, I'll be getting oxidized as well as reduced product. Are able to understand, students? Thank you so much for watching. Please go forward to others to get benefit. Don't forget to subscribe my channel. Thank you so much. Thank you once again. Thank you for learning. Share and like this video.